Hi, welcome back to our next element on the table. This time we're doing barium. As you know, we're still shooting down the table. One more to go, radium. But barium, let's bring up the card straight away. And it's atomic structure. Now, like all the ones in that group, there's 2 electrons in the outer shell, and that makes it really, really reactive. Now, barium has got a nice story, or a bit of a sad story behind it, how it was discovered. In 1774, there was a guy named Carl Scheele. He was Swedish, a chemist, and he discovered a whole bunch of stuff which he hasn't been accredited for. Humphrey Davy usually got the accreditation, but here they are. So he discovered chlorine, tungsten, molybdenum, and hydrogen, and of course barium. Now, he was known as Hard Luck Scheele because he made all the discoveries, but he never got accredited. So big round of applause for him. Thank you very much. Now, it was known as well by the alchemists, but not by its pure form. Here we have a thing called Bologna stones. Now, Bologna stones glow in the dark. It was known by the alchemists. They didn't know it was barium because it was mixed with other things, but they knew it was something new. It was very heavy, and if you left it out in the sun, it glowed. So they got overexcited by that. Couldn't use it to make any gold, but they knew about it. Now, if you have a look at the card, see these blue lines, X-rays, if you remember. There's a few others with X-rays on them. That is X-rays going into barium and barium blocking it. Now, why? Because if you look here, is the small intestine, and large, and all sorts, but soft tissue. Now, you can't take an X-ray of soft tissue, but you can if you have a barium meal. Not by itself, not pure barium. Barium is together with sulfur and oxygen. If you drink it, they can then take an X-ray of your intestines to see if there's a problem, a medical problem. Apparently it doesn't taste very nice. Now, instead, what are X-rays? I mean, very quickly, X-rays are packets of energy in the same way light is, and microwaves and radio waves. In fact, there's a thing called the electromagnetic spectrum. Here it is. Smack in the center is what you're used to. This is visible light. You have eyes which can detect this visible light and convert it into signals for your brain. That's a lot of superhero powers in itself. And as you notice, these light waves, they're longer this end and they're very short, compressed this end. Now, on the long waves, you get things like radio waves and microwaves. And then you're moving on to infrared, which is you emit infrared light by your heat. It's packets of energy moving outwards, waves. And in the center, this is the bit that you can see, the visible light, and then it goes into ultraviolet, then into X-rays, which is what we're talking about here. Barium will scatter X-rays so you can get an image. And then finally, gamma radiation. Really high-powered stuff there, emitted with supernovas or neutron stars colliding, or and don't eat it, otherwise you turn into this guy. Serious anger management issues, so stay away from gamma radiation. And now it's at this point it might be worth trying to get an idea of a scale of the atoms, because barium means heavy. Because it's more dense, it does scatter X-rays. But when you draw an atom, here's a typical atom. This is wildly out of context. This is wildly out of scale. And for example, if you had a ball and a fly downscale and dip it. Now that is the scale, the ball is the scale of the nucleus, the inside, and the fly is the electron. Many, many times smaller. But how far away should they be? Well, in scale terms, they should be nearly 15 miles away from each other. So most of an atom is empty space. Absolute empty space. In fact, it's 99.99 this much empty space in an atom. So it begs the question, why do things feel so solid? Well, it's because when you are touching anything solid, you're not actually touching the atom itself, you're touching the forces that the atoms make. In the same way of putting two negative polarities together on a magnet. They won't touch. There's a force there, but they won't touch unless you really force it. Now, what's it used for? It was used as a getter. Right, what is a getter? Very briefly, these are vacuum tubes. You use them in old electronics and you have to keep them as a vacuum. And air sometimes seeps in. So they did put a coating of barium which sucks up. So that will maintain a vacuum in a vacuum glass. And it's also used if you pull up iron over here and carbon, they make steel. It's important that the carbon granules are small, so they add barium to the granules to make it really small. And last but not least, fireworks. Green fireworks, not red. Last time was red. These ones are green. Barium makes a green light. If you want the free artwork, please email them. See you next week.